this video we will do some more questions from exercise. We'll see what question is given. The question is, write equations showing the ionization of the following as Arrhenius acids. Some chemical compounds are given and we are asked to write their equations to show their ionization as Arrhenius acid. Let's start the session. The first compound which is given is hydrogen iodide. Hydrogen iodide. We'll write the reaction of hydrogen iodide with water to show the ionization of hydrogen iodide in water. So hydrogen iodide, when dissolved in water, in the presence of water, it ionizes to give aqueous hydrogen ion as well as aqueous iodide ion. In the presence of water, hydrogen iodide dissolved to give aqueous hydrogen ion as well as aqueous iodide ion. Since hydrogen iodide dissolved to give proton in water, that's why it is Arrhenius acid. Now we will see what next question is given. In the next question, we are given nitrous acid, HNO2. How can we check the nature of nitrous acid? It is Arrhenius acid or not. If we dissolve nitrous acid in water, nitrous acid dissolve in water. In the presence of water, nitrous acid dissociated to give aqueous hydrogen ion plus aqueous nitrite ion. Since nitrous acid dissolve in water to give proton, that's why it is Arrhenius acid. I hope this is clear. Next question which is given is, write equations showing the ionization of the following as Bronsted Lowery acids. Some compounds are given and we are asked to react these compounds and identify which one is Bronsted Lowery acid. Let's see what is the question. The first compound which is given is nitrous acid. The first compound is nitrous acid, that is HNO2. HNO2. Nitrous acid is given. We will react nitrous acid with water, since in the question we are asked the ionization of these compounds. So nitrous acids, when react with water, ionizes in the presence of water, and after ionization it produces the product which is formed is hydronium ion, as well as we also get nitrite ion. Now in this reaction we will notice H2O, that is water, after accepting one proton from nitrous acid, it changes to hydronium ion. After accepting proton, it changes to hydronium ion. Since water is proton acceptor, that's why it is Bronsted base. So what is the nature of nitrous acid? Nitrous acid is proton donor. Since nitrous acid is proton donor, after donating proton, nitrous acid changes to nitrite ion after donating proton. So that's why it is Bronsted acid. So what is the nature of nitrous acid? Nitrous acid is Bronsted acid, while water is Bronsted base. I hope this is clear. Now we will see the next question which is given. In the next question, we are given hydrogen cyanide, HCN. We react hydrogen cyanide with water, HCN. We do the reaction of hydrogen cyanide with water, and then we will identify which is Bronsted acid. After the reaction, here we get hydronium ion as well as cyanide ion. Now if we carefully look towards the product, we can easily identify which one is Bronsted acid. In this case, hydrogen cyanide changes to cyanide ion. Hydrogen cyanide changes to cyanidine after donating its one of proton to water. Since it is proton donor, hydrogen cyanide is proton donor and proton donor species are Bronsted acids. So, what is Bronsted acid in this question? Hydrogen cyanide is Bronsted acid. Water is proton acceptor. After accepting proton from hydrogen cyanide, water changes to hydronium ion. So, that's why water is Bronsted base. Students, I hope this question is clear. Now we will see what next question is given. In the next question, we are asked to compare the relative concentrations of hydrogen ion and hydroxide ion in each kind of solutions. Some solutions are given and we are asked to compare the concentration of hydrogen ion and hydroxide ion. Now we will solve this question. In the question, the first solution which is given is acidic solution. We are asked to compare the concentration of hydrogen ion and hydroxide ion. In the acidic solution, we know the molar concentration of hydrogen ion is greater as compared to hydroxide ion. So we will write the molar concentration of hydrogen ion. For acidic solution, the molar concentration of hydrogen ion is greater than the molar concentration of hydroxide ion. I hope this is clear. Now we will see the next solution which is given. The next solution which is given is a basic solution. Part number 2, we are given a basic solution and we are asked to compare the concentration of hydrogen ion and hydroxide ion. Now in the basic solution, here we can notice the molar concentration of hydroxide ions. For basic solution, the molar concentration of hydroxide ion is always greater as compared to the molar concentration of hydrogen ion. Clear? Now we will see the next solution which is given. The next solution which is given is a neutral solution. And we will compare the molar concentration of hydrogen and hydroxide ion for neutral solution. We know very well if the solution is neutral, then the molar concentration of hydrogen ion and hydroxide ion are equal. Molar concentration of hydroxide ion is equal to the molar concentration of hydrogen ion for neutral solution. I hope this question is clear to you. Now we will see the next question which is given. Here is the question. Identify Lewis acids and Lewis bases from the following. Some species are given to us and we are asked to identify which one is Lewis acid and which one is Lewis base. Now we will solve this question. The first species which is given is aluminium chloride. The first species which is given is AlCl3. We are asked to identify aluminium chloride is a Lewis acid or a Lewis base. We know very well aluminium chloride is able to accept electron pair. It is electron pair acceptor in a chemical reaction. And we know very well what are Lewis acids. Lewis acids are electron pair acceptor. Since aluminium chloride is electron pair acceptor, it has ability to accept electron pair in a chemical reaction. Since it is electron pair acceptor, that's why what is the nature of aluminium chloride? It is Lewis acid. I hope this is clear. Now we will see what next species which is given. The next species which is given is, the second species which is given is silver iron. Now silver iron is also Lewis acid since it has ability to accept electron pair. It has positive charge on it a positive charged particle or a cation. So that's why it has ability to accept electron pair. Since it is electron pair acceptor, that's why it is Lewis acid. Lewis acid. I hope this is clear. Now we will see the next species which is given. The next species which is given is methyl alcohol or methanol. CH3 OH, and we are asked to identify this species as Lewis acid or Lewis base. We know in methanol, oxygen of methanol has two lone pair of electrons on it. Since it has two electron pair on it, so that's why it has ability to donate electron pair. Since it is electron pair donor, that's why it is Lewis base. We know very well electron pair donor species are Lewis bases. Methanol is electron pair donor, that's why it is Lewis base. Clear? Now we will see what next species is given. The next one which is given is number 4. We are given methylamine CH3NH2, and we are asked to identify its nature as Lewis acid or Lewis base. Now in methylamine there is a lone pair of electron on nitrogen. Since it has electron pair, so that's why it has ability to donate electron pair. It is electron pair donor, that's why it is Lewis base. Electron pair donor species are Lewis bases, so methylamine is Lewis base. Clear? Now we will see the next species which is given. The next species which is given is a cyanidine. Cyanidine has negative charge on it. Since it has negative charge on it, so that's why it is electron pair donor. It is electron pair donor, that's why it is Lewis base. Lewis base. Now we will see the next species which is given. The next species which is given is hydroxidine. A hydroxidine. Hydroxidine has lone pair of electron on oxygen as well as it has a negative charge on it. That's why it has ability to donate electron pair. Since it is electron pair donor, that's why it is Lewis base. We know very well electron pair donor species are Lewis bases. Now we will see what next species is given. The next species which is given is ferric chloride, FeCl3. FeCl3. Now in this species ferric chloride is electron pair acceptor. This species is electron pair acceptor. That's why this is Lewis acid, because we know all those species which are electron pair acceptor, they are Lewis acids. I hope this question is clear.